Hey, I'm Mike. Welcome back to W&D Garage. This video is just going to be me going over the second version of my electric zero-turn mower project. There's going to be a lot of pictures and some bad transitions, but we get what we get. I had several issues and changes that I made for the 2023 mowing season, and we'll start off with the battery. During the winter of 2022, I decided I wanted to break down these server UPS packs and get to the 18650s that are inside and build one monster battery that'll fit inside Craftsman DeWalt, whatever, plastic toolbox so I can sit on the back of the mower. First, I pulled off all the nickel strip on each end of the cells, disassembled them, and then sanded the spot welds off of each end of every single cell. That took forever. I then tested each cell and categorized them into groups based on capacity and designed a 14S pack that I could assemble and then origami back into that toolbox. Testing over 500 18650s took quite a bit of time, and the mega battery that I designed ended up being 30P14S, so that's 30 cells in parallel, 14 in series. And that's 420 cells, which means 1700 spot welds. I will not be doing that again. I used 0.2mm nickel strip to join all the cells. Designing the battery 2 rows wide and 15 cells long would allow me to use this 4 wide nickel strip to then fold it appropriately so it would fit inside the box and I could still have access to the positive and negative leads on each side of the battery. I started off with a cheap spot welder off Amazon that said it could handle 0.3mm nickel strip, and as usual, that was a lie. So then I ordered the PCB-based one, pictured here, that everyone on YouTube says is really good value, but that instantly fried. So I decided to drop some money on pretty much the most expensive handheld spot welder there was on Amazon, and that was about $225 at the time. It welded okay, but the tips are consumable and there's no source to get new ones. I went through all of the tips that were included when I was building 95% of this pack. I had to turn down some copper on the lathe and work harden it so I could finish the spot welds on the pack using that spot welder. For the positive and negative leads, I ended up soldering on the wires before spot welding it onto the battery just to keep the heat out of the cells. After connecting the balance leads and wrapping it in a ton of Kapton tape, I was ready to do the origami. I had the girlfriend come out and check it out before I folded this monstrosity. That's when I made the big whoops. The aluminum block I used as a bus bar had flipped around and pierced the jacket of the cell, creating a short. I just ended up removing those 2 cells that were leaking from the pack, especially since building the pack from the middle out, that group should be one of the highest capacity in that pack. Luckily, everything else seemed okay. I finished folding and added the bus bars, BMS contactor, and the main positive and negative wires. Here's some pictures before it went into the toolbox. And here's the first drive after I added this battery with new drive motors.
Okay.
After that, everything worked great until halfway through the 2023 season when I checked the temperature of the battery after mowing. There were several cells in group 14 that were very hot. The BMS failed and didn't turn off the contactor. The whole cell group 14 was completely dead. I had to take that out of the pack, remove the whole group, and replace with all new good cells. This also meant that I needed a spot welder that could do 2 0.2mm nickel strips to patch it back together. I settled on the Molectric spot welder and it's been fantastic. I should have gotten that one in the very beginning. After replacing the BMS and the bad cells, the battery operated as intended and never even got warm, even when peak amp draws of 160 plus. Since I had found out that the deck motors weren't up to the task of a larger, heavier blade, especially at higher RPM, I had looked around over the winter for a different motor. After finding almost nothing suitable off the shelf that wasn't many hundreds of dollars and already designed for an electric zero-turn mower, and usually proprietary, I found someone on eBay selling this Mac M12500 gardening motor with a non-variable speed controller for a price that I could live with, even if they didn't work. These are rated at 1,000 watts versus the 400 watts of the Ryobi motors. I machined the motor shafts and made another blade adapter like the previous one just for these motors. Cutting the keyway with the lathe was by far the worst part. Well, this is my normal speaking voice, and that's running at 3,000 RPM. I use these motors and the controllers for all of 2023. They're still not amazing, but they get the job done without overheating. They're not programmable, they just run at 3,000 RPM steady. The drive motors not having the torque that I want is the problem that can only be solved by money. I found a similar but much beefier version of the 750 watt gear motors I'd originally used. The new ones are rated at 2.2 kilowatts each, and I ran them at 6 kilowatts. A higher voltage is recommended for these, but I wasn't redesigning everything just for the drive motors. They came with a fan on the end, but I didn't have room for it, so I removed the fan and shroud and machined off the excess motor shaft. I've had zero motor temperature issues after that, so it seems like they were kind of unnecessary. I had issues with the drive controllers overheating in 2022 with the smaller motors, so I knew I needed to address that right away. I added a heatsink to each of the drive controllers, and that resolved that issue until it was 85 degrees outside, and then I'm back to freewheeling down a hill into the road. I added two 40mm fans from an old server that moved some serious air and resolved that issue. Here are some other pictures during this stage of the project. The next video, I'll be going over the full build of EZTR version 3, which I've now used for 2 seasons in a row without modification. Thanks for watching. Later.